Good morning, students. Today I am going to discuss about aldehydes and ketones. Myself, Dr. Ravikumar Naik, working as an assistant professor at Veerashaiva College, Ballari. Today I am going to discuss about BSc 4th semester organic chemistry paper, aldehydes and ketones. Generally, aldehydes and ketones are having carbonyl functional groups. These carbonyl functional groups present in many different biological active compounds. So, like the carbonyl group CO is found in aldehydes and ketones in many other, as I mentioned, many other organic functional groups. So the carbon and oxygen in the carbonyl groups are sp2 hybridized with bond angle of 120 degree. In ketones, two carbon groups are attached to the carbonyl group, while the aldehyde at least one hydrogen atom is attached to the carbon. You can see here different kind of organic compounds, and these are all the different functional groups what we can come across in organic chemistry, and you can find these carbonyl functional groups present each of the different organic compounds. For example, carboxylic acids contain same carbonyl functional groups, esters, C double bond O, anhydrides, CO and CO, acid halides like RCOX, and amide is RCONH2. So you can replace these R functional groups are alkyl by aryl molecules, and we will get a different functional groups or different compounds in organic chemistry. You can see the structure of these carbonyl functional groups. You can see the p orbital of carbon and p orbital of oxygen. The side overlap of p orbitals and p orbitals of oxygen will form a pi bond and the sigma bond, and you can see beautiful of two lone pair of oxygen electrons are present on the oxygens. So as I mentioned, aldehyde and ketone molecules contain carbonyl functional groups, and these two carbonyl, you can see here R and R, here in ketones R and R dash. You just replace R and R dash by hydrogen, the molecule will be aldehyde, and if you are placing alkyl or aryl functional group, the molecule will be ketone. So the nomenclature of aldehyde and ketones, the common names are used. Simplest aldehydes and ketones are formaldehyde, butyraldehyde and benzaldehyde. So here you just replace these two hydrogen by these two alkyl functional group, the molecule will be acetone, and here you just replace it by one of the H by aromatic functional groups, the molecule will be acetophenone, and here you just replace both by aryl functional groups, the molecule will be benzophenone. For aldehyde, starting with the alkane name that correspond to the name of the carbon atom, see what it means that in alkane E is replaced by Al, the molecule becomes an ethanol. See, if you are replaced by OL, the molecule will be alcohol. So very different, very easy to differentiate aldehyde and ketone. Aldehyde and alcohol is in alkanes just replaced by Al will becomes an aldehyde, OL will becomes an alcohol. We have all well studied in alcohols in the third semester. So the best example is acetaldehyde, CH3COH. So like in ketones, the alkanes E is replaced by ONE, the molecule will be propanone. So the propane E is replaced by ONE, the molecule will be propanone. The best example is acetone, CH3CO, CH3. So naming of aldehydes and ketones, you just name this molecule. This is homework for you people. You can easily name this molecule by using this functional group. This is an aldehyde and this is also aldehyde because this COH and this is an alkyl substituents, and this is ketone and this is ketone because this carbonyl functional groups attached with the two different carbon atoms. So you can, like this, you can also name this compound. This is also homework for you people. And name of the compound, this is aldehyde and this is aldehyde, this is also aldehyde. These are all aromatic aldehydes. Easily you can name this. For example, this molecule is having bromo substituents, 4-bromo benzaldehyde. Like this, you can easily name this dimethyl benzaldehyde, and this is ethyl methyl benzaldehyde. So physical properties of aldehyde and ketones, the water solubility of aldehydes and ketones. Generally, smaller aldehyde and ketone molecules have significant water solubility because of their ability to interact with the water through hydrogen bonds and dipole-dipole interaction. What it means that smaller aldehydes means like having smaller carbon atoms. So if you are increasing the carbon atoms or if you are increasing the carbon atom in the chain, the solubility will get decreases. So in the boiling point of aldehyde and ketones, like this, if you are increasing, reverse to the solubility, if you are increasing the carbon atoms, the boiling point will get increases. The beautiful example is propanol, propanone and propanol. You can see these molecules are having same molecular formula but different in structural formula. For example, C3 and H6, here also C3, H6 and O is similar. The boiling point here is 50 and here is 56, just changing in the structure. So if the increase this propanol, 2 propanol, you just, sorry, N propanol, CH3, CH2, CH2OH, it is increased 97 boiling point. So what it means that in aldehyde and ketone have higher boiling points than hydrocarbons of similar size of, because of their ability to interact with the each other through dipole-dipole interaction. So solubility, you can see here water solubility and boiling point. You just see ethanol, propanol, butanol and pentanol in aldehydes just increases number of carbon atoms. The water solubility will get decreases. Simultaneously increase in ketones, the increases the carbon atoms and the solubility will get decreases. So if you are coming to the boiling point, just here the increases the carbon chain, the boiling point will get increases. In aldehydes, like in ketones, increases the carbon chain, the boiling point will get increases. So now we will come across to your proper syllabus. Your syllabus for this semester starts from the synthesis of aldehydes and ketones. So rest of the things, these are all just a brief introduction about aldehydes and ketones. So easily now we will go with the preparation of aldehydes and ketones one by one. So the first method is oxidation of alcohols to produce a carbonyl compounds or to produce aldehydes and ketones. So first, primary alcohol on oxidation it will get aldehyde, and this aldehyde on oxidation it will give carboxylic acids. So the best example is you just replaced R by CH3, ethanol, ethyl, dehydrogenation, oxidation, sorry, alcohol dehydrogenation. So this will give an ethanol, and this is also acetaldehyde, dehydrogenation on oxidation, it will give ethanoic acid. So what it indicates is that the alcohol will becomes an aldehyde. So this leads to how the people will get die when they are consuming the alcohols. Generally, this alcohol will go on dehydrogenation and oxidation, easily it becomes aldehyde. This aldehyde is poisonous for health. So the people will suffer from cancer and they will lose their life. So this is very important. The primary alcohol on oxidation will give aldehyde, and here also you can come across the synthesis of carboxylic acid. So the carboxylic acid we can easily achieve by oxidation of aldehydes. So oxidation of secondary alcohol. Likewise, in the primary alcohol, we just replaced both hydrogen atoms. So in the primary alcohol, we have replaced only one hydrogen atom. You can see here. So in the secondary alcohol, we have replaced two hydrogen atoms by a alkyl substituents. So that means this is secondary alcohol on oxidation. It will give a ketone. What it indicates is that primary alcohols will lead aldehyde, secondary alcohol will lead ketone, because we are having two alkyl substituents, or you can replace by RL substituents also. Easily we can get an acetophenone or benzophenone. So this is the best example is propanone. This is there in your syllabus. So now oxidation of tertiary alcohol. What happens when the oxidation of tertiary alcohol will leads? This tertiary alcohol will on oxidation it will give no result, means the reaction will not get work, because only when this carbon as having OH functional groups as well as it has to having a one hydrogen. The hydrogen is directly attached to this carbon atom where the hydroxyl functional group is attached. Then only this oxidation will lead either acetone or acetaldehyde. In the sense aldehyde or ketones. These are all the examples. These are all the like homework for you people. What happens when this benzaldehyde on oxidation, and what happens this aliphatic aldehyde on oxidation, what happens when ketone on oxidation. So these are all the homework for you people. Now oxidation of alcohols by tolerance reagent. How we can easily differentiate aldehyde and ketones by using tolerance reagent. We have all well studied in the second semester of practical examinations, regular lab. So we will use this tolerance reagent. Tolerance reagent means a silver test or silver mirror test. We will just to differentiate aldehyde and ketones. Aldehyde will results a carboxylate salts and ketone will never give any salts. This means that ketone will not give any result in the presence of tolerance reagent. Only aldehyde gives a precipitate that indicates any compound which is having an aldehyde C double bond OH functional groups. It will give a result and we can easily identify by a silver mirror test. These are all the different examples for you people. You just go ahead with this reaction and find out the solution. So catalytic dehydration of alcohols. How the catalytic dehydration will occur? This is a catalyst, copper catalyst at 300 degrees centigrade. When this primary alcohol on dehydrogenation, you will get acetaldehyde, and secondary alcohol will give an acetone, like oxidation of primary alcohol and secondary alcohol. So this is also dehydrogenation reaction like oxidation. So this is one of the method for the synthesis of acetaldehyde and acetone. This is not there in your syllabus, but even though we are discussing this is also important method. And the second method is synthesis of acetaldehyde acetone by Zem halides. So Zem halides reacted with NaOH strong base and will give dihydroxy functional group molecule. When this, the removal of water molecule gives an acetaldehyde. Similar fashion, we will get an acetone. We can get acetaldehyde acetone by alkynes. So acetylene plus H2O in the presence of mercury sulfate and sulfuric acid, we will get an unstable kind of molecule. And this is not so stable. Immediately, by default, it will use an acetaldehyde and as well as an acetone when you react it with the propylene. So acetylene will give acetaldehyde, propylene will give acetone. So condensation reaction. So wherever the carbonyl functional group C double bond O will present, if you react it with any one of the amine functional groups, you will give a skip base kind of molecules. So these are all the reagents we will make to produce a skip base. Skip base means C double bond N kind of molecule. So what happens when the condensation reaction will happens with hydroxylamine hydrochloride, hydrogen hydrate and phenyl hydrogen. The first general condensation reaction, general method we will discuss. The hydrogen derivative behave like nucleophilic reagent. This is very important. These are all behaves as a nucleophile because the nitrogen will carry always lone pair of electrons. So easily this lone pair of electrons will go and attack the carbonyl functional groups here and it will becomes like this, the intermediate form. Here the proton will get transferred and molecule, this O minus will becomes an OH, then the OH will get removed and with the hydrogen and it will become C double bond N. Here R and R dash is just replaced by here CH3 and here is S, this will become for aldehyde and R and R dash is equal to alkyl or aryl, the molecule will becomes for ketone. So Z means NH2OH and NHC6H5 NaCO3. Because this is the general method, you can make any kind of molecules by substituting these alkyl or aryl functional groups as well as these substituents. So first we will study with the hydroxyl amine means NH2OH. What happens when the NH2OH will react with the acetaldehyde? So here this NH2 will get combined with this O, this easily the removal of water molecule and will become C double bond N here with acetaldehyde oxime and with the acetone also the NH2 will condense with the water these carbonyl functional groups and this gives the removal of water molecule. Acetone, oxime will be the resultant molecule. The similar fashion with hydrogen will get acetaldehyde hydrazone with acetone, acetone hydrazone. So phenyl hydrazine you can easily write the similar like hydroxylamine hydrochloride, like that you can easily write this acetaldehyde phenyl hydrazone and acetone phenyl hydrazone. So here semicarbazide, what happens, this semicarbazide will react with the acetaldehyde, same reaction, only this NH2 will go and react with this carbonyl functional groups. The resultant molecule is acetaldehyde semicarbazone and acetone semicarbazone. So next, the mechanism of nucleophilic addition reaction with Hessian and NaHCO3. So this Hessian means H plus Cn minus Na plus HCO3. This Cn will behave as a nucleophile and HCO3 will behave as a nucleophile because those contains a negative charge or they carries an extra lone pair of electrons will give a negative charge. Hydrogen cyanide and aldehyde are a ketone to form a cyanohydrine. Cyanohydrine means the molecule which contains both hydroxy functional groups as well as cyano functional groups. So adding HCl to a mixture of aldehyde or ketone and excess of sodium cyanide. So excess sodium cyanide is used in order to ensure that some cyanide ion is available to act as a nucleophile. Cyanide ion adds to a carbonyl carbon. The alkoxide ion is protonated by an undissociated molecule of hydrogen cyanide. So mechanism. So this is also general mechanism. If you are replacing R dash is equal to H, the molecule becomes an aldehyde. R and R dash is equal to CH3, the molecule will becomes ketone. Step 1 here, the nucleophile attacks the positively charged carbonyl carbon to form a new bond, and as a new bond is formed, pi bond between the carbon and the oxygen is broken. What in the sense, this double bond, pi bond will start brokening when the nucleophile will goes attached to this carbonyl functional groups. Then this becomes Cn and O minus. So this O minus will attack this H plus and the molecule becomes cyanohydrine. Cyanohydrine means the molecule contains both OH and Cn functional group. So for acetaldehyde, we will have this cyanide, Cn minus will go and attack this acetaldehyde molecule and it will becomes acetaldehyde cyanohydrine. So for acetone, the molecule will become acetone cyanohydrine. Try to write the mechanism of NaCO3, which is very similar to HCN. So reaction involves alpha hydrogens for aldol condensation reaction. So alpha hydrogen means this is like acetaldehyde and this is also acetaldehyde. So this carbonyl functional groups having a carbon and this will becomes an H. So alpha hydrogen, this is involved in the reaction. The molecules are known as aldol condensation product. See the reaction between two functional groups, aldehyde and alcohol. The product, the output product will be contains both alcohol as well as aldehyde functional groups. The molecules are known as aldol products. So here in the first reaction, in the aldol condensation reaction, the reaction will goes in the presence of a base. The base will carries OH minus. This OH minus will abstract this proton and will becomes CH2 minus. Enolate ion means a nucleophile. This acts as a nucleophile and this nucleophile will go and attack this carbonyl functional groups and this carbonyl functional groups here will becomes O minus. Then the O minus easily will abstract proton from the water molecule and it becomes an alcohol. Okay, and this alcohol and this carbonyl functional group, the molecules is known as this aldol product, 3-hydroxy butanol. So for the mechanism of ketone in a similar that of aldehyde, the OH will go and attack this proton and this becomes a nucleophile and this nucleophile will go to this carbonyl functional groups and becomes OH minus and O minus will abstract this proton. This becomes diacetyl alcohol. The mechanism of Cannizzaro reaction in bazaldehyde, the aldehydes which lack in alpha hydrogen when heated with concentrated NaOH under a disproportion reaction. So what it means, concentrated means very concentrated NaOH, not too much diluted. So one half of the aldehyde molecules are oxidized to a carboxylic acid and one half are reduced to an alcohol. This is also an example of redox reaction. See here what happens, the molecule both will becomes an oxidation and both it will becomes a reduction also. This reaction is also known as Cannizzaro's reaction. Aldehyde with alpha hydrogen do not undergo this reaction. Under this condition, aldol product will be formed or favored. You can see here NaOH is reacted with this benzaldehyde, this carbonyl group, this OH is nucleophile will attacks here and this O minus. This O minus will comes back and this hydrogen will go and it will become this removal of the breakage of pi bond here between carbon and oxygen. So this molecule becomes an aldehyde, acid, and this molecule will becomes an alcohol. The ketone is not undergo this reaction because ketone doesn't having a proton here, because we need this hydrogen atom so it will go and gives this product as an alcohol. So therefore only aldehyde will gives in Cannizzaro's reaction, not in any acetophenone or ketones. So Perkin's reaction, in this reaction two different carbonyl group, one must have alpha hydrogen in the presence of base, and this reaction is known as Perkin's reaction, or this reaction is also called as Aldol reaction type. The reaction between acetaldehyde and benzaldehyde, one must be having an alpha hydrogen, and no alpha hydrogen reacts in the presence of a base. In the sense, aldehyde does not having alpha hydrogen, this acetaldehyde is having alpha hydrogen. The mixing between acetaldehyde and benzaldehyde, the reaction will give a Perkin's reaction, or the product is cinnamaldehyde. The reaction is also works in between acid anhydride and benzaldehyde, result same cinnamaldehyde product. See here, this benzaldehyde and this acetone. So this acetone means here we are having one alpha hydrogen. This alpha hydrogen reacted with this benzaldehyde. This is like this product, and this is like proton transformation will give cinnamaldehyde as a product. So similar fashion, Wolff-Fishner reduction. Mechanism is not expected here. They have not asked mechanism. Anyhow, you can aware of this. An aldehyde or a ketone reduced to an alcohol, an hydrocarbon or an amine. The product of the reduction depends on the reducing agent and the structure of carbonyl compound. Here, what happens? The reduction of means C double bond O will become CH2, reduced to CH2 here. Means this functional group is converted to this functional group. But this functional group will not give directly this CH2 functional groups. So we have to react this molecule with one of the nitrogen containing molecules, or like NH2 hydrogen hydride or phenyl then easily we can get this molecule to this molecule. So we can see here, this is like a ketone reacted with NH2 and will becomes this kind of adduct. This adduct reacted with the KOH will becomes ethyl cyclohexane, means conversion of C double bond O to CH2 by the help of NH2 in the presence of base catalyst. So Mannich reaction. Similarly, in the Mannich reaction, carbonyl compounds are treated with the ammonia or a primary amine to form an imine in the presence of hydrogen and a catalyst. So here H2 and platinum acts as a catalyst here, and this is a methylamine. Methylamine reacted with the butanone. So butanone is a ketone molecule reacted with this methylamine, so it will become an adduct like this. This adduct reacted with the platinum catalyst, so it will become methyl secondary butyl amine. So if you have any doubt, please WhatsApp me or write an email. I will clarify your doubts. And because of COVID-19, stay home, stay safe, stay alive. Thank you one and all.